Okay, so I'm going to talk a little bit about induction today. So pretty much I'm going to give you the equation first, which is induction is equal to the change in flux divided by the change in time. This is what we call it. This is induced induction or induced electromotive force. So the easiest way to explain it is the only way to make an electromotive force is to change the flux. So there's a couple of different ways you could change the flux. Let's say we have a loop here, and then we have some bar magnet here. And coming off the bar magnet are some B fields, like such. And this is the B field. The flux is the amount of magnetic field going through this area of loop. So the only time we have an electromotive force is when the flux is changing. So in order to increase or decrease the flux, we either move the bar forward or move the bar back. And those motions will create an electromotive force in this ring. If the magnet is just held at one position next to the ring, no electromotive force can be measured. So there always has to be some motion in order for this to occur. I'm going to do a real quick problem, which has to do with a loop. So the problem is we have a loop perpendicular to a magnetic field. So let's say a loop here, and then we have a magnetic field going in this direction. Okay. The question asks us, what is the total electric motor force given that the magnetic flux changes and time changes? So some real quick variables. We have the area, which is equal to 8 centimeters squared. Then we have the resistance of the loop, which is equal to 2 ohms. Then we have B field final, which is equal to 2.5 Tesla. B initial, which is equal to 0.5 Tesla. Then we have the time. Time final is equal to 1 second. And then time initial is equal to 0 seconds. So this was asking us to find the total electric motive force. So going back to the equation, we have E is equal to the change in B divided by the change in time. So we know the change in B, and we know the change in time, and we know area. And remember that flux is equal to B times A. So we're just going to substitute that in. This is equal to 2.5 times 8 minus 0.5 times 8 divided by 1. So this is equal to 24 volts. And then it asks us to find the current, or the current in the loop given this resistance. So we know that E is equal to IR, so we just modify that a little bit, and we know I is equal to R divided by E, which is equal to 2 ohms divided by 24 volts, which is equal to 0.083 amps, and that's the current in the loop.